Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 40+ UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify innovative applications, build skills and standards, and advance partnerships to solve global challenges. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone. I'm proud to introduce a new set of ITU AI for Good biodiversity webinars. The AI for Biodiversity series aims to share ideas and motivate creative solutions for how AI can support effective and timely actions for monitoring and conserving biodiversity and supporting its sustainable use. I'm Dave Thau, the Global Data and Technology Lead Scientist for WWF. WWF is an independent conservation organization with a global network active in over 100 countries, working to sustain the natural world for the benefit of people and wildlife. And I sit on WWF's global science team. Also hosting this series with me will be Dr. Sarah Beery, Assistant Professor of Artificial Intelligence and Decision Making at the Massachusetts Institute of Technology, and Dr. Lily Xu, Assistant Professor in the School of Industrial Engineering and Operations Research at Columbia University. And together, we're very excited to bring a new set of speakers to the AI for Good Biodiversity series. So what are these webinars about? Well, conservation organizations and others interested in biodiversity have leveraged AI to process sensor data for decades. However, sensor data analysis is just part of what's needed for effective AI application. This iteration of the series will focus on the enabling conditions necessary for impactful AI applications for biodiversity, including things like understanding how AI and biodiversity plays out globally, AI and decision-making in conservation, the role of socioeconomic data, the importance of techniques like federated AI to protect data sovereignty, especially for indigenous and local communities, multimodal applications, the ethical application of AI technology specifically in conservation contexts, and the integration of AI and biodiversity into private sector applications. These webinars, some of which will be live streamed and some pre-recorded, will roll out in the next few months. Today, I'm thrilled to kick the series off with someone I think is the perfect person to give us an overall perspective on the state of AI around the world as it pertains to biodiversity and conservation, Professor Tshilidzi Marwala. Dr. Marwala is Rector of the United Nations University and the UN Undersecretary General. He's a member of numerous academies of science around the globe. He holds a doctorate specializing in artificial intelligence and engineering from the University of Cambridge, has published over 25 books on AI and over 500 articles in journals and book chapters, and he holds 5 patents. Professor Marwala's multidisciplinary research interests apply artificial intelligence to engineering, computer science, finance, social science, and medicine, and he's committed to leveraging technology and global connectedness towards the pursuit of the 17 United Nations Sustainable Development Goals. Several of those goals pertain specifically to biodiversity and the natural world. And when it comes to having a global perspective on how AI can address the challenges we're facing with biodiversity and climate change, I can't think of a better person than Professor Marwala. Rector Marwala, the floor is yours.
Thank you very much, Dave, for inviting me to come and speak about this very important topic of the impact of AI on biodiversity and conservation. Maybe just to add to the very nice introduction that you have already made, I am from South Africa. As you know, South Africa is an interesting country, you know, in terms of biodiversity, but it's also an interesting country because it is slowly becoming a desert with serious consequences in the long term on the future of biodiversity. Of course, as United Nations University and as United Nations, we are concerned about how do you reverse the trend of degradation of biodiversity. And some of these issues I'm going to talk about. And in particular, I'm going to talk about the role of artificial intelligence in managing biodiversity with a view of expanding, certainly expanding the level of biodiversity. And we do that by actually understanding what is going on, using this technology to understand what is going on so that we can deal with this problem. Artificial intelligence, which is the technology of making machines intelligent. And I'm not going to get into the specificities on what it entails to make machines intelligent. It has found applications on a number of areas. One example from our own work is the construction of an artificial larynx that uses artificial intelligence and the movement of the tongue to synthesize the voice when somebody has lost their voice boxes. It's actually an example of the use of artificial intelligence to be able to deal with a practical problem. And then, of course, AI does give quite a great deal of advantages, but it also has its own dark alleys. As a result, there is a need to govern it. And one aspect of governing it is through legislation. And here we have an example of an EU AI Act that has been adopted by the European Union. Our organization as the United Nations, the ITU, actually is involved in AI for good. And of course, this is a powerful statement because you are maximizing the good that comes out of this technology while minimizing its harmful effect. It's always an optimization because while it is useful, while it is being used to do good things, it can also be used to do bad things. And of course, as United Nations University, we are driving the use of AI within the United Nations system and our member states so that it can be used for good. And last year, we launched a United Nations University Global AI Network, which has more than 100 members, organizations, universities, both public and private, who come together to discuss what are some of the mechanisms that we need to put into place so that we can make AI do good things and minimize it doing bad things. And of course, in this specific lecture, we are talking about how AI can be applied to biodiversity. So I'm going to just briefly talk about some aspects of biodiversity that are going to be relevant to my talk. In 2022, the Kunming-Montreal Global Biodiversity Framework that was adopted aimed that by the year 2030, we should halt and reverse biodiversity loss. We should safeguard 30% of the planet's surface, restore 30% of degraded ecosystems, and protect biodiversity hot spots. And of course, for us to be able to achieve all this, we need to identify some of the biggest drivers of biodiversity loss. And this list is not exhaustive. I think habitat loss is, whether it is through the certification, resulting from climate change, for example, the spread of invasive species and diseases, pollution, and over-exploitation of resources. And maybe if I could just give you some statistics, wildlife populations have declined 69% from 1970 to 2018, 94% in Latin America. And of course, for me, this is not necessarily something that is theoretical, it's practical, because in my own village, which used to have a population of 500 people when I was growing up, and now the population has more than multiplied by 20. And all these wild animals that we grew up seeing in our village are no longer there, and the result for that is overpopulation, fueling biodiversity loss. Now, what are some of the contemporary biodiversity challenges? I've already talked about climate change, very, very important. Pollution is another issue that drives biodiversity loss. When our rivers become dirty, then the biodiversity inside the river and also in the general environment actually gets degraded. Habitat loss, destruction of the habitats makes it much more challenging for species to survive and adapt. And of course, invasive species and over-exploitation of resources is another example. And of course, we know of communities around mining towns, something that I have witnessed in my own country, South Africa, and the impact of biodiversity in those areas, which of course calls upon a change in behavior, which is an important concept, that to deal with the issue of biodiversity loss, we need to change our behavior as individuals, as organizations, as governments, very, very crucial. And then the traditional methods alone are absolutely insufficient. I think the traditional methods, I'm just going to talk about 3 of them: creating protected areas, relocating endangered species, implementing legal safeguards. The limitations of these traditional methods is that they are not scalable. Secondly, they are not flexible. And thirdly, they are not responsive. And of course, the changing global landscape requires scalable solutions, depending on how habitat degradation, how fast it is actually progressing, will require a certain level of flexibility for us to be able to arrest the degradation. The proliferation of non-native species, we have done quite well in regulating movement of species between 2 countries, but still, especially in many of our countries in the African continent, the movement of non-native species is an issue that we still need to work on. And of course, climate change is a good example for that. I always indicate that this year, last year, in my own country, South Africa, not even during winter, the snowstorm that killed people because South Africa was just not ready for a snowstorm that lasted for several days, And these are examples of climate change. So the need to be responsive will require us to be able to do some form of prediction. So AI's unique strength in biodiversity conservation include the fact that AI can be able to analyze vast amount of data, and this data can be audio recordings, they can be images. In fact, the whole issue of remote sensing and investigating the level of biodiversity loss is actually quite important, you know. And of course, the issues of adaptive conservation management. I'm reminded of an AI field called genetic algorithms. How do we use lessons from genetic algorithms for us to be able to craft adaptive conservation management system so that an AI system can be able to adjust to conservation strategies over time. Of course, another way in which you can be able to do that is to use reinforcement learning. You know, how do you use reinforcement learning to adaptively conserve our environment? Reduced involvement and efficiency gains. AI powered tools such as drones are able to, can be more effective than human beings. You can be able to scale things up much easier. AI driven drones that are monitoring a geographical space, they can potentially be able to do that much more efficiently than a human inspector would be able to do that. And it minimizes because it is done from the atmosphere instead of from the ground. If I were to drive my truck around a specific geographical area, then I would disturb the environment sometimes negatively, depending on the vulnerability of the space in which I am operating. So there are various ways in which AI can support biodiversity and conservation effort. Predictive modeling in England, for example, identifying pollutants most harmful to biodiversity, combating wildlife trafficking in Uganda and Cambodia using AI to proactively prevent poaching. And of course, ecosystem restoration in Scotland is an example where AI was used to identify individual flare cascades, habitat mapping in Costa Rica, for example, using AI-enhanced audio monitoring of spider monkeys. And then I'm just going to go through some of the examples of the work that we have done. Detection of floods, very important. Flooding actually degrade biodiversity. And this is the work that we did in the Benin Republic. And part of the reason is for us to be able to use AI quite efficiently, we need to have complete data sets. And here, this is the work where we were using AI to impute missing stream flow data at multiple gauging stations in Benin Republic so that we can be able to have a complete story to manage issues of biodiversity. This is another example of the work that we did, dams, systems, and methods for real-time prediction of water level and hazard level of a dam. You know, hazard level might just be pollution, you know, and here we are using sophisticated cameras to be able to do that. The advantage of this technology is that it can be cheap, and because it can be cheap, you can be able to scale it up and and be able to deal with much larger areas than when it is not scaled. One of the things that I have also talked about is due to climate change, many of our spaces are becoming desert, and when they become deserts, the consequence of that is that water becomes scarce. And this is the work that we did using AI system to predict water demand, very important. And of course, it contributes. And then, of course, the use of wind speed predictions. You do have areas that are changing due to climate change, and we need to understand. And here we are forecasting wind speed. The advantage of this is that you can be able to use this technology to create renewable energy stations so that you can be able to get the solution. Now, as United Nations University, there are a number of projects that we are working on with regards to biodiversity. Our institute here in Tokyo, United Nations University Institute of Advanced Study, has launched a book that deals with AI business and biodiversity. Our institute in Germany is working on a project, invasive species into charcoals pilot study in Namibia. And our institute in Canada, Toronto, is working on AI water security monitoring and flood mapping, almost similar to the work that I have just talked about. Our institute in Macau is using AI to combat wildlife crime workshop. And our institute in Bonn in Germany, the other one, Flores, is in Dresden in Germany. This one in Bonn, we organized a meeting last year on how to contextualize artificial intelligence within the context of climate change. And in the upcoming months, we are going to be launching an AI institute in Beijing, in Bologna, that focuses on the algorithmic aspect of AI and how it can be applied to deal with issues such as the climate change modeling. We have just launched a hub, a United Nations University hub in Beijing that deals with how AI can be governed, and some of the issues that needs to be governed is the energy utilization of AI. And we know that if the source of energy is non-renewable, then biodiversity becomes a victim. The water utilization of AI system in the cooling part of data centers that emit quite a large amount of energy, and therefore there's a need to cool the temperatures down using water. And of course, this has bearing on sustainability, especially in low water resource places. So what are some of the limitations of AI in biodiversity conservation? I think data quality and availability is still a big issue. I think the issue of algorithmic bias is also an issue that we should be worried about. I think the issues of the ethics of it, while it gives us good things, how about the energy utilization? How do we design the energy ecosystem so that it does not, contribute towards biodiversity degradation? The issues of financial barriers, especially in the global south, becomes quite important. And there are also issues of technical barriers, which we as the United Nations University, we are actually working on how do you bring AI expertise to the global south How do you bring AI to the people where the issues of profit and loss and maximization of profit is not an objective. The issue of data sovereignty and local knowledge is very important because much of the AI systems are actually being trained in the global north. When you go to the global south, there is a need to contextualize those models to those local conditions. So maybe just to talk about some of the hidden footprint of AI, and this is just an example of here in Japan. By 2026, the total electricity consumption of AI data centers could reach more than 1,000 terawatts hour. And this is more or less equivalent to Japan's annual electricity consumption. I think the conclusion is that AI systems are energy hungry. And by 2027, the global demand for AI is projected to consume 4.2 to 6.6 billion cubic meters of water, 4 to 6 times the water consumption of Denmark. You can see some of the things that we need to deal with. Now, coming to the responsible governance of AI, we need to develop ethical frameworks and governance structures to ensure that AI initiatives serve the common good. This will entail finding the right balance between algorithmic insights and human oversight to ensure that transparency and accountability are part of the implementation of AI, foster engagement and literacy on the ethical use of AI, and bring together stakeholders from across sectors and disciplines and convene on ethical use of AI and include the voices of the Global South. And for us to be able to do this, we need to ensure that we develop values that are going to define the governance model. Secondly, we need to, through education, nurture human and organizational behavior that promotes responsible AI. We need to create the necessary incentives so that AI is used to maximize the good and minimize the bad. We need to have policies and regulations. We need to have standards. We need to have laws. And we need to have institutional structures that are going to help us promote responsible AI governance. In conclusion, our task is to harness this powerful technology to accelerate sustainable development while mitigating its harms. That was UN Deputy Secretary General Amina Mohammed. Thank you very much.
Great. Thank you, Dr. Marwala. I loved how you brought it to your own upbringing and your own town and the relevance to that and the breadth of applications you showed us. There was so many different topics. It was great to see all those examples. And at the end, you touched on something, one of the questions that I have, and I asked sort of my network to bring questions to me for you also, and many of them were relevant. So it's around the what you just ended up with, which was the need for governance systems that apply everywhere. Um, and you've written about sort of trade-offs and between sort of local governance and global governance and how to measure those. I'm wondering if you think there are fundamental differences in how AI governance should be implemented in different regions and how to go about that. And the related questions I got, I'll just share those with you too. One was Gabriel, who's from Amazonas in Brazil. He asks, how can AI technologies support indigenous peoples and local communities in asserting sovereignty over their biodiversity data while ensuring fair benefit sharing tracking? And how can AI be used to challenge technology colonization? And Wari Nikwi from Ecuador in the Imbabura province asks about participation in Latin America, particularly in indigenous people's rights and in data and data sovereignty. So do you have thoughts about the like how governance can play out in a way that's both globally and locally relevant?
No, I mean, these are quite difficult questions. Look, I mean, I think governance models differ depending on who is responsible. It is clear that some aspects of governance model must actually be done at the international level. For example, one aspect of governance of AI involves the use of data. And if we are actually dealing with issues of modeling water flow of a river that moves from one country to another, and I come from the African continent, and there is such a river that crosses 11 different countries. It is called the River Nile. So what needs to happen is that data must be shared. Cross-border data becomes important. Cross-border data cannot be done by one country because it crosses different boundaries. It has to be done by multiple countries. Multilateralism becomes an important aspect of cross-border data. Then you would have issues about the energy utilization governance model. Some of the governance models might just be best practices, you know. Who govern that? Is it done at the national level or is done at the international level? Then you can have issues around algorithmic choice, because all these models, at the end of the day, somebody sits down and say, I'm going to use a multi-layer perceptron to do this. And this multi-layer perceptron is going to have so many layers and so on and so forth, you know. I don't think you can have a government involved in that. So I think industry standards becomes very important. IEEE has developed some of those benchmarks, you know. So the idea of a balance between what needs to be done at the international level, what needs to be done at the national level, what needs to be done by industry itself is very important. And all these things must be harmonized. We need to know who is doing what, because if we don't, then things can actually fall down the crack. When we talk about AI and indigenous knowledge, I mean, I come from South Africa, and I have seen my language being integrated into Google Translate. I don't know who owns the IP to my language, you know. It's an old IP. It's an old language. And of course, coming from South Africa, when we talk about old languages, we really mean it, because the oldest languages that are spoken in the world are actually in my country. Khoisan, which is probably the only language that you can be able to speak, and without necessarily using much of the voice box, because it is a clicking language and clicks happen in the mouth, are in my country. So there are issues of IP that we need to deal with, but there are also issues of learning from indigenous knowledge. I always say that the first person to teach me about AI was not my professors at Cambridge University. It was my grandmother, who used to make clay pots, and she will knock each pot and listen to the sound, and based on the or on the length of the ringing of the pot, you will know whether it is a good pot or not. So when I went to do a PhD on the use of neural networks to detect faults on systems, same concept, different technology. So there is lessons that we can learn from indigenous knowledge. And it goes both ways. How can we use AI to preserve some of the things that are disappearing, such as languages? Indigenous communities are losing simply because there are just not enough people who are supporting those languages. Those are quite important issues. The third question that you asked was about, what was it about?
Was about ensuring, so Gabriel is asking about technology colonialization or colonization.
Look, I mean, colonization is a difficult word.
Yeah.
Colonization is a difficult word because there is all of us have been colonized by technology. All of us, when we wake up in the morning, the first thing we reach for is some technological device. So our psychology has already been colonized. And it's not necessarily good, and it's not necessarily bad, because with that technology, there's a great deal that we can be able to do. But if it becomes an addiction, then we have issues. Now, that is just one example. Another example is the idea of how these technologies are created. These technologies are created in one part of the world, and they are used in another part of the world. Unless these technologies incorporate what is happening on the other side of the world, then the people who are on the other side of the world are forced to adapt their culture to reflect the values of another culture. I'm one of those people who believe that cross-cultural exchange is actually not necessarily bad. You know, in fact, it is good. So for us, I think we just need to make sure that the technology is inclusive. The data sets reflect the diversity of the world as we know it. That this technology is not used to create instruments of warfare that is going to be used to subjugate, but is going to be used to improve effectiveness of medical care, to improve, to bring education to rural areas like where I come from, Dutuni, to bring the diversity of the world to almost a singular culture place like where I come from. I mean, these are good things, and it should not be just a one-sided story.
Right. Yeah. So inclusive technology development and co-development is the key to this.
Absolutely.
Yeah. Great. Yeah, you just touched on another question that I had, which was about education. So you've written about the fourth industrial age and how it impacts higher education. I'm wondering if the UN University is doing anything in terms of that, in terms of training current students who are interested in leveraging AI to achieve the Sustainable Development Goals, in particular in biodiversity.
Absolutely. No, we are obviously quite an interested party when it comes to issues of capacity development in education. And I think the element is, how do you use AI Firstly, I think how do you expand AI literacy? And this is a universal goal, because even the textbooks that ought to be used are not really perfected yet, and we contribute towards the writing of those books. We contribute towards the highlighting some of the big issues that we need to be careful about. What are some of the issues that we need to be careful about? The current state of the art as far as AI technology is concerned is based on a statistical concept called the maximum likelihood approach. And the maximum likelihood approach basically by design minimizes rare events. And if I were to use probabilistic distribution functions, it minimizes events that are at the tail of the normal distribution function. If we assume that this is a normal distribution function, Gaussian distribution function. And of course, you would not be able to see when you are dealing with issues that are mainstream. For those of us, and this perhaps also links to the issue of colonization, for those of us who come from languages that are the so-called low-resourced languages, we know very well, too well, that we just have to ask it about one or two things, and it would not be able to know because those things are not at the dominant part of the probability distributions functions. Yeah.
Mm-hmm. Right. Do you see in the this university system that you're working within sort of interest in biodiversity and climate change, and how are the sort of the students or the curricula being developed around those things?
Look, I mean, to be honest with you, we push, our students are quite aware of biodiversity. I don't think that is where the problem actually lies. The problem is actually when you go out into industry.
Uh-huh.
The problem is that the payoff of developing a good application makes developers of this technology even forget about the concept of making this technology efficient so that it can be able to use less energy, so that it can be able to use less water. The concept of efficient algorithms, as far as I am concerned, has been forgotten. All these large matrices that are used, that is why you have NVIDIA chips, because you have to do quite a large amounts of matrices that have to be done in parallel, and I remember too well when we used to spend a lot of time thinking about how do you efficiently calculate eigenvalues and eigenvectors. Today they will tell you, well, why are you worried about efficiency? While you are sorting out about efficiency, somebody is going to reach the market first. So that is why governance is very important. Because if the only governing fitness function is maximization of payoff, then biodiversity degradation is going to happen because applications are not going to be efficient, and the important research theme of making these algorithms efficient will not be taken into account.
Yeah. Yeah, there are all these small models that are being developed and are useful. And so you can, if you want, try to minimize your own energy use by using one of the smaller models. Um,
Of
but
course, of course, of course, of
but
course.
but it's not easy.
No,
And
but what I see is that, of course, there is a profit payoff, especially when you take these small models into mobile apps.
Hmm.
You know, you have this big model, and of course you can run it from the cloud, and much of these applications are being run from the cloud. I mean, if you look at most of the applications that we use, they won't run them in the devices because maybe they are not going to be as effective, so they run them from the cloud. When I use my word processing or app here in my computer, it is on my computer.
Hmm.
And once I mean, a computer there's huge amounts of memory, so there's not really much need to make the algorithm small. But when you go into the mobile devices, there is a business case to make them small.
Uh-huh.
But I don't think it should be just because of that. We need to create models that are efficient, not necessarily just because we want to put them on mobile apps, because efficient models are good for the environment.
Yeah.
And we need to go to the cloud and say, how is the utilization of resources in the cloud? Because what
Right.
happens in the cloud, there's very little regard of computational efficiency. In fact, most of the clouds only use a fraction of their size.
Mm. Yeah. I always thought it should be easier to monitor your own, you know, emissions whenever you're using these models. It's so mysterious. You don't have no idea. Like when I fly, I know
Hmm.
what my emissions are. When I'm using a large language model, I don't. It's like something that I really should be in place. Uh,
Or when we are having communicating now,
oh
how
yeah,
much
exactly.
how much energy are we using, and what can we do to be able to, well, the good thing is that we have not flown,
Yes,
so we are on the efficient, well, not efficient, we are better off than if we had flown.
that's right. Okay, you're touching on a question that comes from Guillermo, who is from Arizona in the US. That's very relevant to what we're just talking about now. He asks, looking ahead, do you envision a future where AI enables entirely new economic models rooted in conservation, where protecting biodiversity becomes more profitable than exploiting it? And what role might AI play in reshaping how societies value and invest in natural ecosystems?
Well, I mean, I don't think it's AI. I think it's human beings.
Uh,
I think it's human beings that are going to sort it out. I mean, you can actually be able to create an AI that is powered by energy that comes from renewable sources. But a human being decides otherwise. You know, we can create an AI that is efficient, but it's a human being that will need to make the investment into efficient AI. You so yes, technology itself can be whatever we want it to be.
hmm,
Of course, there are limits of science, there are limits of what is known, what we know. But I think the biggest issue is how do you change the behavior of humans and organizations so that we can get the outcome that the colleague from Arizona has just raised. What is the role of behavioral science?
yeah,
Without necessarily being deceptive, because I think sometimes some of these nudges are deceptive, you know, and there are ethical issues around them. How do we create incentives? Because incentives is a big issue. Profit is an incentive.
hmm,
How do we change the incentive equation? Difficult issue to do, so that human being that sit in an organization or that sit in behind the desk and use this technology or develop this technology actually does the right things. And you have issues of policies. What are the policies that we need to put into place? What are the regulations that we need to put into place? What are the standards? What aspects can be regulated and they can be put into law? I seem to remember when I was still much younger than I am now, reading somewhere a powerful statement that said, morality cannot be legislated. Not everything that needs to be done can be put into a law. Some of it will have to be guidelines. Some of it will have to be best practice. Some of it will have to be policies that are not specific, that require somebody to still go and make choices, you know. Whether you use efficient conjugate gradient method or inefficient traditional Monte Carlo method, somebody will have to sit down and decide on that. Even if you automate it, somebody will have to construct the fitness function that will decide how you're going to do it. Ultimately, a human agent is still a very important aspect. And through education, through reminding ourselves of our values that are based on the UN Charter and the Declaration of Human Rights, we can actually be able to achieve sustainability.
Okay. Yeah. Yeah, you've written a lot on AI and policy, but I think that will take a lot of time to go into, and we are almost out of time. Um, so I wanted just to have one last question, I think, which is, as the person, in your position in the UN, um, what message would you give to young innovators, or global stakeholders who want to use AI for nature and climate? Like, do you have a takeaway message for young people who might be interested in going into this area and looking for something to do? Do you have any thoughts for those folks?
I think for me, the message is very simple. It starts with me. It starts with me. In my own language, even that there is a proverb that says that when you are pointing a finger at another person, there are three fingers pointing at you. So you are the change, as Mahatma Gandhi said. You must be the change that you want to see. So if you can be able to take the right steps, and all of us can be able to take the right steps and be responsible and make the choices that take into account sustainability and the protection of many things, including biodiversity, then we are all going to succeed.
All right. Great. Well, thank you so much for your time and for your work, for the information you shared with us. Uh, it's very inspirational, and it's a great way to set off the rest of the series. We'll be talking more about a lot of the things that we touched on, and more than that. And so it's all about what we can do to ensure that AI can be used, to benefit biodiversity, nature, and the humans who depend on it. So thank you again, Rector Marwala. It's been an absolute pleasure talking with you.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.